Okay, so welcome back everybody. Now for the next presentation where Asian management. Everybody, let's give it a big round.
Good morning, everyone. My time is taking 2 minutes to set it up. So my talk is about message queues, and I am Nation Member. I am currently serving as the quality and maintenance lead at Memcached. I've been there for like 2 years. You can follow me at Geshan is my Twitter handle, and that's my blog. So let's talk about the agenda index for this particular presentation. I'm basically going to talk about what is a message queue and what are some message queue basics. Then I'm going to go into the benefits of it. Then one particular vendor, that is RabbitMQ, and more of like how we are using it. So this is going to be much of a practical presentation, and I'm not going to show you any code. And the other disclaimer I have is I just prepared like this 14-slide presentation, I don't know, yesterday evening and today. So if you find typos and stuff like that, that's normal because I didn't have time to do this. Okay, so let's start off with what is a message queue. Wikipedia has its own definition, saying it's like kind of inter-process communication thread, this and that. But I'm not very satisfied with that. I would basically say it's a software component that allows producers to produce messages to a queue, and using a message broker, so the producers don't talk directly to the queue. They just give the message to a message broker. It's the responsibility of the message broker to decide which queue to send it to. And that particular message is then asynchronous. The keyword here is asynchronous. It's consumed by a consumer. What's happening here, in case you are like lost or you have any questions, you can interrupt me anytime. If it's like the first time you are hearing about message queues, could be. So you can interrupt me anytime, and if you have anything, you can ask me. By the way, how many of you have used message queues here? 1, 2, 3. Okay. So at least there are some people who already know about it. So it's going to be very important. So what are the message queues basics? Let me get the whole slide, then it's easier. Okay, so this is a communication protocol based on AMQP, Advanced Message Queuing Protocol, and STOMP. That's a long full form. You can read it there. So basically, what happens, as I said earlier, is there is a message producer. Okay, that is giving a message to generally a broker. It's called a broker or an exchange. Then, as per the things sent in the header, the broker decides to which queue to send that particular message to. There could be multiple queues. And then, as the message is in a queue, there would or there can be generally one or multiple consumers listening to it. And consumers are generally daemons. By that I mean they are running processes. So they are generally not the ones that just are there for one request or for 10 minutes and they die out. No, they are daemons. So that means a queue is generally always listened by at least one of the consumers. So that's why it is asynchronous, it is fast, scalable, and those things I'll go on to discuss ahead. So what are the benefits of using a message queue? The primary benefit is decoupling. Let's say that that your message producer is a system in Java. Could be. And then your message consumer is another system in PHP. So in that case, if you want to decouple the code between a Java system and a PHP system and still make them work together, because they speak the same language in between, let's say JSON, which is a message. So let's say Java system sends you a message saying, I don't know, export this order, or I don't know, send the SMS, better, notification, send the SMS. So the Java system will send a message to the exchange. The exchange sees, okay, this should go to the notification queue. Let's say that the QA is notification. As the PHP consumer, the consumer A is always there. As soon as it gets the message, it says, send a message. Message is this, phone number is this. So compile it, send it to the related recipient. So that's how you can do coupling. Scalability. You can scale up. As I said, one queue can have multiple consumers. So in that case, if you have something intensive, by the way, both the talks that were before me, the RESTful thing and the imagine thing, they are very much, could be very much used with the message queues. How, I'll go on later. In case of scalability, because of these reasons, you can scale out. And then now you have cloud services for message queues. That means you could like virtually scale as much as you want. In terms of performance, there is one point I'll clarify later. Reliability, yes, because the message queues itself can be durable. Reliability also in a sense. Let me go back again to this picture. So let's say your whole system, all of your consumers are dead. The Java system is working fine. You put your PHP system locally in Nepal, there is a load shedding, it went out. The Java system is in some AWS server, it's running fine. But the Java server sent a message to send the SMS. It somehow reached the queue. Your queue server is also somewhere secure and it is fine. But as the consumer is not there, the message is still there. And if your queue is durable, that means even if the RabbitMQ server restarts, the messages will still be there. By that I mean, as soon as your consumers, the PHP system is back, it is again able to read those messages. That's why it is purely asynchronous. You can start publishing messages and then it stays to the queue. As soon as your consumers are back, they are processing again. So that means they are quite reliable and durable. Fan out is like a type of queue. Probably I mentioned it in a previous slide. That basically means that you will have some routing rules that will send it to all the queues. So if you want to do a pop-sub method, publisher subscriber stuff, so you can do it and then you can send it to all the queues and all the consumers can get it. So that's also an advantage of using queues. Probably there are a lot others, but these are some of the ones that I know and that we are kind of using. So RabbitMQ, one of the vendors. There is IronMQ, there is ZeroMQ, there is something from Oracle, there is something from Microsoft as far as I know, but the ones we are using is RabbitMQ, it is open source, and it fits our needs at least. The features of RabbitMQ. These are all just taken from the RabbitMQ website. You can go to rabbitmq.com and yeah, just have a look there. As I already said, it's not going to be like code intensive, so you'll have to do some of your own research if you want to really write something related to the queues. I'm just going to give an overview of why you should be using it and how would it help you. Okay, so let's talk about the software stack that we are using at Memcached. Memcached is basically a rocket internet venture, an e-commerce website, so maybe the examples I give in the other slides will be more about e-commerce. Just bear with it. By that, we are using Symfony 2. We are using Symfony 2 with the whole sound RabbitMQ bundle. We have made some small modifications to it, but generally it's the same code that is there in the whole sound RabbitMQ bundle. By the way, how many of you are using Symfony or Zen or any other system? 1, 2, 3, 4, 5. Okay, so basically Symfony is a framework. You could make it an MVC, you could make it a glue framework, you could use the Spark components of it. So as far as you know what Symfony is, I think that's fine. Bundle is find the equivalent to modules in Zen and all the other stuff. So in case if you don't know that, that's a very brief introduction to Symfony. I think he also talked about Symfony stuff. Then we are using RabbitMQ. I don't exactly remember the version. Maybe it's 3 point something something. I don't really remember the version right now. And we are using the Cloud AMQP service, SaaS service. I don't know the number of servers and stuff like that, but yeah, that's pretty fine. If you want to try it, we also have a free model. So if you want to experiment around and if you don't want to install stuff on your machine, you can try it. Or even better, if you want to do it, you can use backend like he is doing and not pollute your main system. So it's all up to you on how you want to do it. And yes, after his talk on RESTful stuff, you should look into SOA, like how you can like really make services out of having REST systems and making them work together. By that I mean we have like a service for just users, we have a service for products, we have a different service for checkout and stuff like that. So that means checkout is very important. Even if the user service is down, maybe people can't register, but you can still check out. So that's why you should go into a service-oriented architecture, service-oriented model. Okay, so that's like mainly things related to the RabbitMQ stuff we are using. Yes, let's talk about this. This is going to be interesting. So when should I really use? There is a producer, there is a message, there are some consumers, stuff are going on. Why should I use it? Like that's the real question. First thing is, let's say a backend and front end sync. How many of you have used Drupal or heard about it? Okay, and how many of you think that it's slow? A lot of you. If you haven't used it in production, you don't know. But if you have used it in production, it's slow. Why? Every refresh, go to the database page, things show on the view. Very slow. What's the slowest part? The database. So rather than that, why don't you get everything, process it into like a key value pair, put it into a NoSQL or a Memcached storage. Refresh, go to the Memcached storage. If it's there, serve. Else, go back and do this cycle. Then I think it will be at least 3 or 4 times faster, even in a very bad infrastructure. So caching, right? This is what I mean. So the backend, there is a lot of things about products and everything. But then for speed, for scalability, for all the other reasons, there is always a middle layer. In our case, we were using Memcached and now we shifted to Redis. So this was like the old implementation was not that good.
Shifted to what?
We shifted to Redis.
Redis. Okay.
Redis. We were in Memcached. So this is the old implementation was not good. Why? Because we are.
Can you tell me a little bit benefits of using Redis over Memcached?
Redis over Memcached. One, Memcached, if you restart, everything is gone. So on the developer machine, if you by chance restart your backend or something, nothing. That's a very bad thing. Speed-wise, Redis is a little better. I cannot say you exactly what percent and stuff like that. But yes, even speed and scalability-wise, Redis is better. And as it is no SQL, restart still stays there. So those are the benefits that I can just think of right now. Yeah, that's it. Anything else?
I think it can handle more complex data like graph data and all.
Yeah. But for now, yeah, exactly. You're totally right. But as in our implementation, we have it for a kind of key value store. That's it. It's nothing like graph. Okay. So coming back to this, our old implementation was like a 1-minute cron. Our very bad implementation, everything, all the changes that you make on the back end, like you change product details and stuff like that, go to a table, cron runs every minute, it goes and processes it, very bad. And the new one. So, stuff changes at the back end user interface, okay, goes directly to the queue. The same old diagram, I don't want to go there again. Goes to the queue. Goes to the queue via the exchange, that's for sure. And there is always at least one consumer listening to the queue. So save here, almost instant consumed, changes on the website front end. That's very good. So very good for backend front end integration. And let's say if you are selling a news website or like a very client-centric website, think of this. Because every refresh, go to the database, 80% time trying to get the data from the database, the website is good. Okay, a very good system to communicate between internal systems even without APIs. How? So I was once consulting with a travel company here in Kathmandu itself, and we had a problem that they had a different system in another place, and we were building like the front-end website. trying to communicate those two things, data was complicated. They were not willing to open APIs. We were not a big enough team to do APIs. So if I had knew like a system like RabbitMQ or any best-in queues at that time, I would have really opted for it. So in that case, what would have happened is that backend system would write something to the queue. Our system would read it from the queue and consume it. Same thing, like it comes from here, left to right, right to left. That would have been a lot easier. Then no one has to open APIs. All you need to do is like agree upon these are the messages that we are going to publish, probably JSON, and then consume it. That's it. Asynchronous third-party API calls. Again, I would like to give some examples relating to the e-commerce stuff. So what do I mean by asynchronous third-party API calls here is like, let's say your order is packed at the warehouse. It's ready to be shipped. And you are using FedEx. And you are using FedEx as your shipping partner. So your order is packed at the warehouse, and then the warehouse sends something to system X, and that is going to create the shipment. Okay? And let's assume that creating the shipment takes 10 seconds. That's too much, but let's say 5 seconds. Because FedEx, as far as I know, has a heavy soap very, very heavy soap request to be sent, and then you need to send all those things like order items, addresses, and stuff like that. So the data is not applied. System A sends a request to System B, create me a shipment, please. System B gets the message and instantly replies to System A. I will be creating the shipment, ask me later. This guy gets the message, puts it in the queue. Queue does the processing, sends the message to FedEx system. FedEx comes back saying blah blah system is created. It's all an AWP airway bill. That's the package ID. Okay, and says blah blah system is created. Our people will come, I don't know, in half an hour or something, or tomorrow morning and pick it up. That's the general communication. So system B now has the AWP. That means the thing is created in FedEx. System A sent this message. Let's say 5 minutes message. 5 minutes later, system A sends to system B, get shipment blah blah. Just say get shipment with X ID. Then this has the system. So it is not waiting for 10 seconds for this to reply, go to third party, get the element back, and then come back again. So in this case, asynchronous calls are a very good place to use. Notifications like SMS and emails. No one's going to kill you if the order confirmation email is 30 seconds late. But people will surely ask you questions if the checkout is broken because you could not send an email, right? So the things which are like even of low priority is not like those things. So you should be able to check out at any cost. Even if you can't send email, that's not a big question. You'll have the phone number of the person, you can call him up. One lost customer is a very bad thing to the company, right? So in that case, you could send all your notifications like emails, SMS, you could even do an integration with WhatsApp and stuff like that later. So all your notification can stay there. There is a consumer waiting for the messages, then it will be processed. If your load is high, don't put one consumer, put 3, all the messages will be cleared in no time. Handling last request asynchronously. What do I mean by this? So again, I'll go back to an example. Let's say I have a warehouse system A and our system, the website system B. So warehouse system A at the end of the day, let's say at 12 or 1 a.m. every day. Whoa. Fine, I'll go on talking. Maybe we can press this. So the warehouse system at like 1 a.m. in the day will send all the things that were shipped to the website system B. And let's say you have 5,000 orders a day and equating to around 7,000 items. So, and let's say that day 3,000 items were shipped. 3,000 items, same XML comes here. If you start processing it and then want to reply to this guy, you're lost. Because processing all those 3,000 items, the best system in the world would at least take like 10 seconds. So making a client wait for 10 seconds, I don't think is a good idea. So you get like the XML for those 3,000 items, you say, I got them. You put it in the queue, someone's going to process it. And maybe after like 2 minutes, you can again go back and say, okay, I processed them, or the system can ask you, were you successful to process them and stuff like that. If you have any questions till now, you can ask me. Because I don't know why I'm so lucky, so that it went out.
Oh, it's okay. नेपालीमा ठ्याक्क भन्दा के हो नेपाली
Sorry?
पहिला इन्जिनियरिङ पढ्दा प्रोड्युसर कन्ज्युमर भनेर एउटा सिस्टम युएसमा पढाएको
Is it good for that? That's the first question. Is it good for that?
प्रोड्युसरले प्रोड्युस गर्ने कन्ज्युमरले कन्ज्युमर युएसमा पढाएको
Sort of like
अपरेटिङ सिस्टम पढ्दाखेरि पढाएको अब त्योभित्र अपरेटिङ सिस्टम त बेट्टोको कुरा हो है
If it's really a production ready system.
the news website.
नाम्सीमा चाहिँ कतिवटा अहिले प्रोड्युसर कन्ज्युमरहरू कतिवटा सर्भर
Server as a server.
प्रोड्युसर र कन्ज्युमरहरूको डिफ्रेन्ट सर्भर छ कि एउटै सर्भरले
Well, we are hosting it in that cloud API stuff.
मलाई यो कुरा कम्प्लेन
And पहिला चाहिँ हामीले आफै होस्ट गर्दा थियौँ.
अहिले चाहिँ कहाँ क्लाउडको
मैले अघि देखाएको थिएँ नि.
CloudAMQ.
cloudam.com or something like that. So पहिला चाहिँ हामीले आफै होस्ट गर्दा थियौँ हैन.
मलाई एउटा बुझ्न मन लागेको कुरा के हो जस्तो कि अघि भन्यो नि एउटा चाहिँ प्रडक्ट पर्चेज र चेकआउटमा चाहिँ छुट्याउने एउटै सिस्टमलाई चेकआउटको पार्टलाई कसरी छुट्याउने त्यो अनि त्यो के अरे
Product part.
प्रडक्टको पार्ट
Okay. What's the term? Very good. Very good question. So, as in, you can separate it. सबै गरेर proper SaaS बनाएर तपाईँ पुरा product र तपाईँको चेकआउटलाई अलग-अलगै डेटाबेस अलग-अलगै गरेर पनि छुट्याउन सक्नुहुन्छ. अलग-अलगै गरेर पनि छुट्याउन सक्नुहुन्छ. नत्र तपाईँको सिस्टम डेटाबेस चाहिँ एउटै राखेर अगाडिको लेयर मात्रै अलगै गऱ्यो हैन. अगाडिको लेयर मात्रै अलग गऱ्यो चेकआउटलाई तपाईँले क्याच गर्न सक्नुहुन्छ पोस्ट गरेर हैन. तर तपाईँको ट्रक देखाउनलाई चाहिँ सेयर क्याच गर्न सक्नुहुन्छ हैन. सो त्यसलाई रेस्टफुल एपिआई बनाए माथिबाट भार्निस लगाइदियो फास्ट. यतापट्टिको तपाईँको यो अलगै सिस्टम छ. सो लाराभेल युज गरे पनि प्रोडक्ट बन्डल चेकआउट बन्डल अनि युआरएल फर्म checkout.mysite.com go to mysite.com.
चेकआउटलाई डिफ्रेन्टै
checkout.mysite.com finish. आज तपाईँको लाराभेलमा छ भोलि गएर जेन हुन्छ सर पर्सि गएर सिस्टम एकदम सिक्योर चाहियो अरे भनेर आयो अनि पोसिबल.
सेसन चाहिँ के डाटाबेसमा राख्नु नभए
सेसन राख्दैन होला.
अनि
There is nothing like this.
क्युमै राख्नु
There is nothing. क्युमा राख्नु There is nothing like this.
सेसन कसरी मेन्टेन गर्नु फेरि जस्तै
म त्यहाँ त्यो पछि म सकेपछि पछि मलाई क्वेसन गर्नु होला त्यो सम्झाउनु.
मलाई एउटा चाहिएको अगाडि प्रोडक्ट भयो प्रोडक्ट भयो पनि एउटा सर्ट गरेर अनि सोलर हाल्यो स्ट्याटिक डेटा
Let's go back. मलाई त्यो question सम्झाउनु होला म त्यहाँ आउँछु तपाईँ सम्झाउनुलाई. So yeah, handling very large requests asynchronously. As I said, you get an XML of like 3,000 updates. You don't reply to the client when you get it. Send it to the queue. Someone else will process it. Maybe 5 of them will process it, and then you come back and say. Or if it's not mission critical, you never reply to the system A. System B does its stuff. Done. Processing intensive tasks like image resizing. I didn't know that you were doing a talk on Imagine. By the way, the code he showed, even the very easy ones would take 10 seconds or even more, right? So why do it like synchronously? Someone sends you, someone uploads you a picture, you have to resize it. Why do it when he is uploaded? Why can't you do it? You just get the file, put it in the queue. Some other consumer is going to resize it and then put it in the database or do something like that. Things like that. It's very good for that. Other processing intensive stuff is not coming to my mind. If I have something,
I'll tell you what I have to do in a website, video processing. video is uploaded.
Yeah, right.
And then processing from FFmpeg, don't ask me how much time it's going to take.
I know.
So it was like you have to upload it and wait for processing. And
You're right. But in those cases, probably you cannot use multiple consumers because the thing cannot be split into multiple tasks. If you have any algorithm that can split those stuff, let's say you can split a video into 4 files, 4 consumers do it, and then join another queue that joins the thing, then it will be even faster.
Yeah, I think what I have to do, Right
like
now,
let's say if it's a 5-minute video, you put like 1.5, 1.5, 1.5, like 4 chunks, process them, make it zip, I don't know, MPG or something from another thing. Then another queue is there which joins them again.
Yeah.
So like that you could these things are needed for performance and scalability.
जस्तो कि मैले रिसेन्टली एउटा काम के गर्नु पऱ्यो भन्दाखेरि 26 GB को XML फाइल छ ठुलो. डोन्ट आस्क मी व्हाई हैन XML हुँदैन तर XML फाइल चाहिँ 26 GB. त्यसलाई मलाई इम्पोर्ट गर्नुपर्ने थियो हैन. अब मैले के गरेँ भन्दाखेरि सेल लेखेँ त्यसलाई टुक्र्याएँ अनि प्रत्येकमा चाहिँ जस्तो कन्ज्युमर यसलाई त्यो सिनेरियोलाई मेसेज क्यूमा हाल्दाखेरि अझै फास्ट हुन्छ कि
म अझै त्यो भन्दै थिएँ. म चाहिँ के भन्छु भन्दाखेरि तपाईले XML लाई डेटाबेसमा ल्याउनु पर्यो. राइट. सो त्यसको लागि चाहिँ राम्रो अप्सन हुन्थ्यो लोड डाटा इन फाइल. XML लाई CSV बनाउने टेम्प डिरेक्टरीमा हाल्ने टेम्प डिरेक्टरीले तान्ने तर 27 GB नहोने साइजेबल चंक्स. यो काम गर्नलाई यु कुड हेभ क्यू समवेयर इन between.
भन्नाले XML लाई CSV मा कन्भर्ट गर्ने भयो.
XML to CSV first. CSV goes to a temporary table.
What if I have to insert this data in multiple tables?
Multiple tables, no problem. Would it be a problem? Problem then, as long as you have it in a temporary table, you can select parts of it and put it anywhere.
भनेपछि मैले XML पास गरेर CSV पनि मैले मल्टिपल CSV नै बनाउनु पर्यो. टेबल स्पेसिफिक भएर बनाउनु पर्यो CSV.
That would be a design choice you will have to make, depending on the data, depending on your process. In context, can I use a message queue in that? Yes, but it will need like a good software architecture thinking before writing. And you cannot go write code and then change stuff and try to inject an MQ because you think you need it. You first have to be sure you need it and then write code.
किन भन्दाखेरि मैले चाहिँ 26 GB को डेटा किन भन्दाखेरि इट्स अपडेट थिङ हैन इन्सर्ट मात्रै होइन कि पहिला एक्जिस्टिङ डेटा छ त्यसको पहिलासम्म रिभिजन नम्बर चेक गरेर छ कि छैन भन्ने कुरा थुप्रो कुरा छ त्यसमा कि.
Fine. In that case, we are using RabbitMQ to do stock updates. Stock updates and checkout are like the two most important things to any e-commerce business if you guys have worked on it. So that thing comes like every 4 hours and we update the whole table. Because our system does not have the stock, right? Stock is like a physical count of I have 2 bottles. SKU blah 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 2 bottles. That is the knowledge that rests on the warehouse. So warehouse every 4 hours sends like a huge thing. As far as I know, around 50,000 SKUs, and we are processing them every 4 hours. So I am not saying it is like very difficult or impossible. 27 GB data is huge. I agree.
27 GB ma 13 million records.
13 million records, like that's still huge. But then you need a strategy to correctly separate them. My suggestion would be go for load data in file. Why? Because it's faster. You should not be doing a loop insert or a bulk insert.
खासमा के हो भने म लोड डेटा इन फाइलबाट XML को उसमा लोड डेटा इन फाइल गर्दाखेरि किन भन्दाखेरि उनीहरूले ठुलो चङ्क दियो कि CSV फाइल पनि ठुलो GB मै दियो के हैन त्यो GB लाई इम्पोर्ट गर्दाखेरि पनि टाइम लाग्यो लगभग 6 देखि 7 आवर्स लाग्यो त्यो इम्पोर्ट गर्दा हैन. मैले अनि XML मा के भन्दा 36 वटा के 26 भन्दा माथिबाट फाइललाई प्रोसेस गरेर के स्प्लिट गरेर प्रत्येकमा चाहिँ मैले प्यारलल प्रोसेस गराएँ.
Depending upon the
त्यो गर्दाखेरि मेरो सबै गर्दाखेरि
depending upon if your data overlaps or not, त्यसमा डिपेन्ड गर्छ मेरो डिजाइन. तपाईले फेरि मल्टिपल टेबल्स कुरा गर्नु
मल्टिपल टेबल
हैन त्यो हो भने अब तपाईको त्यही हो. फेरि आम ब्याक टु द सेम सफ्टवेयर आर्किटेक्चर तपाईको डेटा अनुसार तपाईले आर्किटेक्चर गरेर 5 वटा क्यू हुन्छ हरेक क्यूलाई म 3टा कन्ज्युमर दिन्छु यसले यो पर्टिकुलर क्यूले यो ABC भन्ने टेबललाई मा डेटा फिल गर्छ B भन्नेले गर्छ भनेर भन्नुहुन्छ भने त्यो गर्न सकिन्छ. 1 प्यारलल प्रोसेस भयो. 1 2 तपाईले अब डिपेन्ड गर्छ तपाईको सिस्टम कस्तो छ. आफ्नो लोकल सिस्टममा 27 GB डेटा प्रोसेस गर्न थाल्यो भने त थाहा छ होला.
AWS मै हो सर.
भनेपछि AWS हो भने मसिन स्मल लार्ज साइज हेरेर
मिडियममा छ
प्रोसेसिङ कतिको छ त्यसमा हेरेर डिपेन्ड गर्छ. सो अब त्यो एउटा त सानो डेटा सेट लिएर पाइलट गर्नु 2-3 सेकेन्ड मात्रै डेटा लिएर पाइलट गर्नु अनि त्यहाँबाट पर्फर्मेन्स हेर्नु